Okay, so what's up everyone? This is Akshay here, and let us continue with today's GFG registry. Today's question name is Game of Zor. It's a medium category question, but I would say it's maybe a standard one. Not a standard one, but a bit observational one, right? Let us read the question. So we've been given an array of size n. We need to find the value of an array. Okay, the value of the array is generated by the bitwise Zor of all the elements. Okay, find the bitwise Zor of all the values of all the subarrays of A. So basically, we need to find form all the subarrays of the given array, right? And you get the XOR of those values. So these are all the possible subarrays. That is the individual element 1, 2, and 3. Then the possible subarrays are 1, 2, 2, 3, and 1, 2, 3. So we need to get the XOR of those values. So one basic approach or one brute force approach would be that you form all the subarrays, right? Forming all the subarrays will give you the time constant of O of n square, and you take out the XOR of all the elements, right? So and space complexity would be O of 1 for this approach, that is to form all subarrays, right? What would be the method 2? So method 2, so what is XOR actually? If you do A XOR A equals to, it becomes 0, right? How the bitwise XOR reacts? So if the bits are different, right, then the value is 1, and if the bits are same, then the value is 0, correct? So we just need to leverage this property. So if you are able to find that among all the possible subarrays, what is the frequency of each and every element, right? Because let's say if 2 is repeated twice, that is even times, and definitely 0. Or if 2 is repeated 4 times, right, then definitely 0. So if it is occurring odd times, then only my answer will differ, right? The even same number would be coming to 0, and then this odd will create a problem, right? We'll have some answers. So let us form the array. So let us first decide the even case. The even elements are there, right? So what is the number of occurrences of 1 in all this particular subarrays? So forming subarray would be 1, where the 1 included, so 1, 2, and 3, and similarly 1, 2, 3, and 4, right? So you can clearly see the number of ones are 4 here. Similarly for 2, the arrays would be 2, 2, 3, and 2, 3, 4, right? So 3, or let me write it for you to make it more understandable. 2, 2, 3, and then 2, 3, 4, right? So you can clearly see that the number of occurrences of 2 here is 3 times, right? But then again, this 2 is also coming from the subarrays formed using this one. So it is nothing but total subarray, that is 4 minus 1, again 3 times. So 3 plus 3 is 6. So 3, it is coming from this side, and then another values are coming from, that is the values present from the previous terms, that is the total value minus 1. So 3 plus 3, it is 6. So again, it is even. Again for 3, what will happen? So 2 subarray will form from here. So 2, there would be twice the 3 will occurring, and then it would be coming from the previous state as well, right? So this was 3. You can clearly see 2 would be coming, uh, the occurrence of 3 would be coming twice, again from the states formed from starting from 2. Then again, 3 more occurrences of 3 would be coming from the states formed using this one. So it is again 3 to 6 and 8, right? Similarly for this 4, you can clearly see, or you may calculate it, it would be 1 plus what else, 1 plus 1 plus then again it was 6, right? So the total occurrences of 4 you can count is 4, 1, 2, 3, and 4. So it would be again 4. If you see, the weightage or the frequency of all the elements here is even. So for 1 it is 4, for 2 it is 6, for 3 it is 8, I guess. Okay. So for 2, how many 2's are there? It is 6, correct? And let us tally from the manual run as well. So for 3, how many occurrences of 3? So it is 2, 3, 4, 5, and 6. So it is 6, again it is even. And for 4, you can get the count of 4 as 4, right? On all the possible subarrays. So this is all the possible subarrays, right? You can clearly see all the count of the given element is in even number, right? So if you get the XOR of these values, everybody will contribute the weightage as 0, right? So if length, or if the array length, is even, then the only answer we have is 0. Just return 0. Let us see what will happen in the odd case now. Let us see what will happen in the odd case. So let us take a smaller example in this case. So let us take 1, 2, and 3, right? So for 1, what are the possible subarrays? 1, 1, 2, 1, 2, and 3. Similarly, starting from 2, it is 2, and 2, 3. Starting from 3, it is just 3. Let us get the count of occurrences of 1, 2, and 3. So 1, you can clearly see it is 3 times 1. For 2, you can clearly see it is 2 times. For 3, it is the occurrences 1, 2, and 3 3 times. Okay, so let us add one more element, 4, and here the array would be 1, 2, 3, and 4, and 2, 3, 4, and then again 3 and 4, and then 4. So let us count again. So what are the count again is now? So it is 1 and 3 and 4. So again it is 4, right? Okay, so that would be an even case, right? That would be an even case. So again, let us not add it. So in the odd case, odd length, so what are the final values? The occurrence of 1 is 3, so definitely we have to put this element, that is, for I equals to 0, I have to consider that element. For I equals to 1, I do not have to consider it because it is even, right? And for I equals to 3, it is again odd. So for I equals to 3, I have to again, so considering the pattern, for I equals to 5, I have to consider it again. I equals to 2, consider it. I equals to 4, consider it. And then 6, similarly, and 8. So all even number indexes, right? So okay, so this is first thing. Second thing is that run a for loop for I equals to 0 till n, and just get the XOR values of the even indexes, and that's it. We'll be getting our answers, right? So that's the core in Java. That's what we have done. If n percent equals 0, return 0, and if it is an odd case, that is the number of elements are odd, then definitely consider the even cases, take the XOR of those elements, and then return the answer. So that is it. What would be the time and space complexity? So the time and space would be O of n as time and O of 1 as space. Great, so that question has been done again. So yep, few last thing that you can start and fork my DSA repository to get help with the source code. And I hope you're solving the question from this sheet as well. So we'll be covering this sheet entirely from the first question to the last 194 question. And as I said, so we are going on a good pace. So I've already covered 7 plus 7, 13 videos. I have already covered 13 videos, or let's say 13 questions. I have mentioned the video link as well. In the approaches section, I will mention all the approaches possible, and with the comment as well. So it would be, once you solve it, and then it will be very easy for me and you guys also to revise the same concepts, right? So great. Let us meet again in the tomorrow's week. Till then, keep learning, keep growing. Bye bye, and take care, guys.